Hello, Algebra 2 folks, and welcome to Unit 2 Linear Functions Continued. So today we are going to talk about literal equations and what it means to be a literal equation and how to solve variables within literal equations. So you need your notes, you need a pen or a pencil, and you possibly need a calculator. So the first thing we're going to do, as we always do, is talk about the learning target. The learning target today is that you are able to isolate a specific variable using mathematical operations. And when we isolate for a variable or solve for a variable, remember we're using inverse operations. Okay, so what is a literal equation? Well, hopefully you've all taken geometry, so you've seen literal equations. They just weren't called literal equations. So a literal equation is an equation with more than one variable. So if you were in geometry last year, which I'm hoping you all were, you would have seen a squared plus b squared equals c squared. That's the Pythagorean theorem. It's an equation that has three different variables in it. Or how about area? Area equals 1/2 base times height. That has three variables in it as well. And so some of the other examples that you'll see that just doesn't relate to math, but outside of the math world would be in chemistry. The ideal gas law, PV equals nRT, density. Density equals mass divided by volume. And in physics, you might see the kinetic energy equation, okay? So know that literal equations aren't just meant for math, they're out there in other subjects as well, okay? So today we're going to look at them and we're going to learn how to solve or isolate for a specific variable within the equation, all right? So here is example number 1. We want to solve this literal equation for R. Now it's already solved for C, so it would be awesome if we had information where we could just plug 2 pi and whatever the value of R is in there. But when it says to solve for R, the reason why we do this is because sometimes it's easier to find the values when we have the variable we want isolated. Okay, so we are going to solve for R. Before we can do that, we have to know the operations that are happening between the 2, the pi, and the R. Okay, so what is the operation here? The operation isn't add or subtract or divide because you don't see any of those signs. So the operation is, yep, most of you already have that, it's multiply. So if you don't see an operation, more than likely it's multiplication. Now the only time that's not the case is, remember when we did compositions last chapter? Yeah, those don't mean multiply. Those mean to compose. So you just have to be careful, but most of the time, if you don't see it, it means multiply. All right, so the inverse operation of multiplying would be dividing. So you're going to go ahead and divide both sides by 2 pi. Well, what you do to one side, you must do to the other. That's why I said 2 sides. The 2's cancel, the pi's cancel, and you're left with R. R is equal to C over 2 pi. Okay, so we just solved this equation for R. Okay, let's solve this equation for X. Yeah, you already have it in Y equals, but I want it X equals. All right, so we are going to figure out how to get 3/4 X alone. So to do that, I need to subtract B from both sides first. So Y minus B equals 3/4 X. Now, last week when we were solving equations, we talked about not dividing by a fraction. Okay, same is true here. We can't divide by a fraction, but we can multiply by the reciprocal. Okay, and when we multiply this side by the reciprocal, 3 times 4 is 12, 4 times 3 is 12, and 12 divided by 12 is 1. Okay, so the 3/4 and the 3/4 are going to cancel to make X. I'm going to multiply this side by 4/3 as well. Now, notice I used parentheses. because what you do to one side, you have to do to everything on the other. So we don't just multiply 4/3 times the y, we have to multiply 4/3 times the b as well. So this would be 4/3 y minus 4/3 b. And that would be the answer to example number 2. Example number 3, solve for y. So again, I've got to get y alone. So in order for me to get the 3y alone, I'm going to have to subtract 8x to both sides. 3y equals 48 minus 8x. Notice I cannot add these two together because they are not like terms. And now to do the inverse of 3y, which means 3 times y, we're going to divide by 3. And a lot of times people forget to divide everything by 3. A lot of times I'll see this. I prefer that you go ahead and divide every term by 3 as shown. Okay, so this would be 48 divided by 3 in your calculators would be 16. And 8/3 doesn't reduce, so I'll leave it as -8 over 3x equals, these 3's cancel, and we've got y alone. Okay, let's try another one. We're going to solve for r in p equals 2 pi r plus 2x. So again, I'm going to try to get r alone. Before I can do that, I got to get rid of anything extra over here. So we're going to subtract 2x from both sides. We've got p minus 2x equals 2 pi r. We're going to get r alone by dividing everything by the 2 pi right away. Okay, if multiple things are being multiplied right away, in the end here, you can go ahead and do them all at the same time. So this would be divide by 2 pi, and I would get p over 2 pi minus 2x over 2 pi, because this means everything is divided by the 2 pi, and then these 2's can cancel, and I'm left with p over 2 pi minus x over pi equals r. Now this is really important to be able to get to here if you're going into calculus. I would definitely be okay with you ending at this point for now, but there is something to be said for being able to simplify further as you get up into the higher math classes. So either one is acceptable for right now, but if you are going to be in a higher math class, you may want to take some opportunities to learn this sooner than later. All right, example number 5, we're going to solve for A. Okay, so we have C alone, and then we have AB plus 8 over 12. This one's kind of scary because a lot of people want to subtract that 8 right away. But this right here is a grouping symbol. And this division has to be taken care of before you can do anything with the top. So the first thing you should do is multiply by 12 on both sides. The 12's cancel over there. You're left with AB plus 8 equals 12C. Now we can go ahead and say, let's subtract both sides by 8. Cancel the 8 over here. We have AB equals 12C minus 8. And then I want to get A alone, so I'm going to go ahead and divide by B on both sides. And I'm going to divide everything by B on both sides. So I have A equals, because the B's cancel, 12C, let me erase that, I'm sorry, 12C divided by B, subtract 8 over B. Or you can also have A is equal to 12C subtract 8 all over B. So either one of these answers, again, is acceptable, except for I would like you to shoot for the higher ability of simplifying fractions, okay? And then for the last one we have is to solve for P. But as you notice, this one looks a little bit different. This one has 2 P's in it, okay? So before we can solve for P, we got to get those 2 P's that are over here on the right-hand side just alone and by themselves, okay? Because we can't get P alone if there's other things plus the P's. So we need to get rid of this negative T. So the first thing I'm going to do is I'm going to add T to both sides. I kind of loop my T's so they don't look like ones or plus signs. And then I have R plus T equals PT plus PS. All right, so in this case, since we have 2 P's on this side, we are going to factor this P out. Okay, we're going to take it away from both of these terms. So I'm going to divide this term by a P, and I'm going to divide that term by a P. And what happens is I'm going to end up with T plus S. Okay, and how do I know that that is right? Well, if I took P times T, wouldn't I get PT? And if I took P times S, wouldn't I get PS? So if you re-multiply these out and you get back to the original, then you know you divided the P out correctly. Now, what I can do is I can divide by TS on both sides because this P is being multiplied by all of this, and the opposite of multiplication is division. So I'm going to multiply this side by T plus S, and I'm going to divide this side by T plus S and divide this side by T plus S. So these 2 T's plus S's cancel out, because anything divided by themselves is 1. And I will have R plus T over T plus S equals P. Now the only thing that you have to be careful with is this does not say R over T plus T over S. It doesn't break down into this. That is not correct, okay? R is being divided by T and S, and T is being divided by T and S. So we're going to just leave this in this form because we're not going to be simplifying those types of fractions until probably around April or beginning of May. Okay, so we're going to stay right here with the R plus T divided by the T plus S equals P. All right, so what you learned today is what a literal equation is. It's an equation that has more than one variable, and that we use literal equations so we can solve for different variables. And we have to use inverse operations. All right, that's all I have for you today. Peace out. We'll see you next class.